everyone, in this video we will solve GATE 2022 ME Set 1 question number 43. This question is from the topic fluid mechanics. The question is a solid spherical bead of lead of diameter 0.1 mm sinks with a constant velocity v in a large stagnant pool of liquid. The coefficient of drag is given by CD is equal to 24 over RE, where RE is the Reynolds number and is defined on the basis of the diameter of the bead. Now, the drag force acting on the bead is expressed by this expression, and we are supposed to calculate the velocity of the bead. Now, let's look at the theory we need to solve this question. So, first thing we need to know is how a Reynolds number is defined on the basis of the diameter. So, here this expression Re is equal to rho v d over mu gives you the Reynolds number on the basis of the diameter, where rho is the density of the body, v is the velocity, and d is the diameter. Also, mu is the dynamic viscosity of the fluid. So this is the viscosity. So Re is rho Vd by mu, and also you need to know the forces experienced by a body which is sinking in a fluid. So here in this illustration we see this black circle. This, let's suppose this is like the bead. So this is your uh, lead bead, and this is sinking with a velocity capital V, and the various forces that act on this bead is, and okay, this blue patch is the patch of fluid in which the bead is sinking. So this W gives you the weight of the lead bed. So W gives you the weight of the lead bead going down, and then because of the fluid, this body experiences a drag which is in the upward direction, and Fd, this is the drag force, is in the upward direction. Also, the body can also experience a buoyant force given by this Fb. So these are the various forces acting on it, and let's see how we can solve this question now. So let's move on to the solution. So let's draw our schematic again. This is the fluid. This is our lead bead. This is the weight force which will be given by mg, and then the bead will also experience this drag Fd and some buoyancy probably given by Fb. But so the net force will be given by W minus Fb is equal to Fd, and since it is sinking with a constant velocity, thus these two forces will balance, uh, these three forces. But also in the question they have given that the buoyant forces can be neglected, so we can say that Fb can be neglected, and then we get this balance between the weight of the lead bead and the drag force. Now the weight is simply given by m times g, and the mass of the bead can be written as density of the bead times the volume of the bead times g. And since it's a spherical body, we can easily find its volume. So volume will be given by 4 by 3 pi times r cube, or 4 by 3 pi times d by 2 cube, which is nothing but 1 by 6 pi d cube. Thus the weight of the lead bead becomes rho times 1 by 6 pi d cube times g. So let's name this equation as 1, this as 2. Now in the question they have already given us the expression for the drag force. So Fd here is called capital D and is given by CD times 0.5 rho capital V square pi d square by 4. Now also we have been given that CD is nothing but 24 over RE. Now in the last slide we just saw that RE is given by rho times V times D over mu, and we get the expression for CD as 24 over rho times V times D over mu. And now we can substitute CD here and find what FD will be. FD or D, which is nothing but 24 times mu times rho VD, and we have 0.5 here, rho V square pi D square over 4. Now let's call this equation 3. So now we can take equation 1, 2 and 3 together, and we can say that D is equal to W, which implies that 24 times mu times 0.5 rho V square pi D square over 4 over rho V D is nothing but rho 1 over G pi D cube G. Now all the other terms are known to us. We just need to find V, which is the velocity. Now solving for V, so this V gets cancelled, one rho gets cancelled, and this D gets cancelled, and we have been given that D is equal to 0.1 mm, rho is equal to 1100 kg per meter cube, and mu is nothing but 0.1 into 10 to the minus 3. So we can substitute all of these terms along with G being 10, and we'll find that velocity is 1 over 18 meter per second. So we solve this question and we find that the velocity V is option C, 1 by 18. And in order to know more about this topic, you can refer to the NPTEL course video on Introduction to Fluid Mechanics by Professor Suman Chakravarti from IIT Kharagpur.